50. We have a parallel plate capacitor, a plate area 10.5 square centimeters, and a plate separation 2D of 7.12 millimeters. The left gap of the capacitor is filled with the dielectric constant of K121. The top of the right half is filled with the dielectric constant of K242, and the bottom of the right is filled with material of dielectric constant K358. What's the total capacitance? Well, again, just a quick reminder, you can split this up, and I'm actually drawing it like this. It's two capacitors really in parallel. What I want to focus first on is this right-hand side. If you look at those two capacitors, you can think about those as two capacitors in series. The part with K2 is then in series with the part that has kappa or K3. Let's figure out the capacitance of both of those first of all. So let's work with K2. So the capacitance of that top portion of the right side is going to be K2 times the area times epsilon naught over D. Plugging in our numbers, the area in this case is going to be half of this area. Since the total area is 10.5, we're dealing with just half of the area from here to here. And so it's going to be this. And again, just a quick reminder, square centimeters converting to square meters, our regular SI unit. Don't forget there's 100 centimeters by 100 centimeters in each square meter. And so when I convert this into square meters, 10 to the minus fourth. Same thing with the distance. The total distance is 7.12 millimeters. In this case, we're dealing with just half of that. So 3.56 times 10 to the minus third meters. Solving that, we get a capacitance for that is about that. Going to do the same thing for the bottom right-hand side, except now we're dealing with kappa 3. Plugging in the numbers, area and distance stay the same, it's just kappa that changes, giving us that capacitance. Again, reminder, these two capacitors are in series, one after another. You can think about this, pretend there's a metal plate right here connected to the metal plate and the one below it. So in series, again, our rule is we simply need to add up the reciprocals. If we do that, we'll find the total capacitance of the right side is that. Now, let's figure out the left-hand side of the capacitor. If we do that, again, just kappa 1, plugging in that, which is 21. This time we're dealing with the total distance, the 7.12 millimeters. Area is still half of the total area. And we'll get the capacitance there. Now, the left and right-hand side of this capacitor are in parallel. So all I need to do is add up the answer we had before with the answer we just got. And if you do that, you'll discover the total capacitance is this, about 5.92 times 10 to the minus 11 farads, or you could write it as 59.2 picofarads. Hope this helps.